like mean evolution is happening. So if there's mutation, it's evolving. If there's gene flow, genetic drift, non-random mating, or natural selection, these all cause evolution. So for Hardy-Weinberg theorem to be like valid, none of these things can be happening. So we can use a Hardy-Weinberg principle to see if a population is evolving, because we can like set up a chi-square and know what our expected values would be in that population, because they shouldn't change. Like my frequency of P and Q should not change if the population is not evolving. And I can compare those expected values to what the population is actually doing, and I can run chi-square using that. So if P or Q allele frequencies change, then I know I'm not in Hardy-Weinberg equilibrium. Let's look here at number 2. We have a large population of randomly mating rabbits, and they contain 28% of white rabbits. The allele from white fur is recessive to the allele for brown fur. So this right here, now that I know that that's a recessive allele is white, I'm going to change this to 0.28, get it out of a percentage. And now this is my recessive phenotype. P, Q, Q squared, P squared, 2PQ, what is that? All right, so that's Q squared. So now I have that. Once we know that, we can calculate all of the genotypic and phenotypic frequencies for the population, now that I have Q squared. So let's look at, let's see, what's dominant? Brown. So we'll calculate all of these genotypes, and then we'll calculate the phenotypes, white or brown fur. I already know my frequency for my phenotypes for one of them, because I know that white is 0.28. How would I find the brown phenotype really fast? Subtract from 1. So 1 minus 0.28, what is that? 0.72? 0.72. So those are done. Which one do we know right away over here? Little b, because that is, well, I know will give me the white phenotype. So this is 0.28. So that's done. So what's my strategy for the next two? Remember, this is P squared, this is 2PQ, and they gave us Q squared. Seema? No, because brown could be homozygous dominant or it could be heterozygous. And I don't know how they're distributed. Peyton? Okay, so we'll do that. We'll first take the square root of 0.28 to find out what Q was. So somebody do, Ben, what is it? 0.53. 0.53. Once we have that, we can find P, because P plus Q equals 1. So someone take 1 minus 0.53, is that 0.47? Now that I know Q and I know P, it's a lot easier, because this is P squared. So 0.47 squared, 0.2209. And now the last one is 2 times P times Q. 0.4982. All of these should equal 1 or 100%. So 5. It looks pretty close to 1 to me. How are we feeling on that one? So that one was a lot like number 1. They just gave us less information. Last one for Hardy-Weinberg. I think you guys saw this. Like, I think I gave this to you when I taught it to you, but you probably forgot. So we have 1 in 2,500 babies is born with cystic fibrosis in the U.S. each year. Cystic fibrosis is a genetic disease caused by a recessive allele. So is this an allele frequency or is it a phenotypic frequency? It's a phenotype because we're talking about babies who have phenotypes. So is that Q squared, 2PQ, or P squared? Which one is it? Q squared because it's recessive. Because it told me that it was a recessive disease. So we want to know the frequency of the genotype of individuals in the population born with cystic fibrosis. The genotype would be homozygous recessive, which would be Q squared. So I would just have to take 1 divided by 2,500. This would be the genotype and the phenotype because it's a recessive disorder. What's 1 divided by 2,500? 0.3 zeros? And then a 4? Okay. Now we want to know the percentage of the populations who are carriers. What does it mean to be a carrier? Carriers would be like someone who's heterozygous, so they want us to find 2PQ. This is Q squared. I need to find Q, then I need to find P, and then I can find 2PQ. So, find Q, that will be the square root of this. 0.02. Okay. P, what is that? 0.98. 2 times P times Q would give us my carriers. 0.0392. So that's my frequency of carriers. If they just ask for frequency, I'm going to leave it in a decimal. If they get tricky and they ask for what percentage of the population, then you just need to move the decimal over 2 if they ask for a percentage. But I don't convert it unless they ask you for a percentage. So that would mean like 3.92% of the population are carriers. All right, those of you who are at a 3, did you move up a little bit? We can move on? Okay. I have a few